Hello and welcome to video 6 of our Python Minecraft version. Video 6. So, first I've got to remind myself of where we got to last time. And in this video what we want to do is create an infinite terrain using our system or developing our system from what we've got already. So, we've imported a giant model. We've got our terrain generating using Perlin noise, and I think, do I press F? Yes, I can press F to then build blocks, and I think this is the last thing that we did. Oh yeah, we can use the number keys to switch between block types, and yep, I can also kind of like mine or at least delete the blocks that we've created individually. Oh yeah, and we've also got different colors for different parts of the terrain. Okay, so that's where we got to last time. What I want to show you is this different system that I've been working on. Apologies that it's been a week or maybe more than a week since this video, but I've been working on a few things and I've struggled to get time. But here we go. Here's my kind of updated behind the scenes version, which looks a lot more like classic Minecraft. And good news is, wherever we walk, we can now generate terrain. And in fact, if I just stand still, you'll notice what happens is the terrain generates in a circle around the player, or what I like to call the subject, the person's like position. And notice I am videoing, but we've got somewhere between 30 and 60 frames per second. What happens in terms of performance actually is that when we're generating the terrain, as you might imagine, the frame rate drops to around 30, although it's holding now to 60. But we can build in things like I can press G and that turns off generating the terrain, and we should get nicer performance. In fact, it's very silky even though I'm recording, which I'm really pleased with. And so now, technically speaking, we could keep on walking for as long as we like, and we've got that infinite terrain. So exactly what we want. And what I was really pleased with, which we'll also do in this video, I think, I'm planning, is we can actually design a more sophisticated texture for each of our blocks to make our terrains look a lot better. And I'm not great at texturing, and I only did this one in a hurry. Actually, I spent a little bit of time with it. I'm not really experienced, but I'm quite pleased with that, like first go, at least anyway. Right, so let's close this one down. And what I had a couple of comments ready. So Swadhi Chitwani has asked, hello, please make a video on infinite terrain generation. And I think I said, about a week ago, I'll do that in the next video. So here's the next video. Thank you, Swadhi, for watching. And I'll try and be fairly clear in my explanation. And Anushtub, Carl, sorry if I pronounced your name wrong, sorry. Or Kale. Why did it say Carly? Maybe it's Kale. Anush, can I call you Anush? Thank you, Anush. Doubt from the tutorial. When we get to the area where blocks are, there are invisible blocks. Can we get blocks there? So hopefully what I just showed you is exactly what you wanted. It's what I want, so we can go anywhere and create an infinite terrain. So that's what we're going to aim to do. And when you said there are invisible blocks, if you remember, they are the shell blocks. Where are we? The shellies. 3x3 grid, I think is perfect, by the way. My experiments behind the scenes, 3x3 is the most efficient way of doing it. So let's keep that number to 3. So 9, that will generate a grid of 9 blocks altogether. 3 across, 3 down, in terms of rows and columns. And so this, generate the shell, it's creating, those invisible cubes with colliders where we can stand. Right, let's set up our files. So what I suggest you do is not change everything in your most up-to-date file if you've been doing that way, but let's copy everything from tutorial 5 and we'll make a new file, and then just in my IDE here I've just got to select Python and go paste all of the old code, and let's call this tutorial 6. Obviously you don't have to call yours tutorial 6, but I'm just marking it, and then let's save that in the folder we were in before. So I'm in my tutorial folder, yeah, so I've got tutorial 1 up to 5, and this will be my tutorial 6. So let's just call that, oh, I can't select one, I'm going to have to type it out. Fair enough. Right, pycraft underscore tut underscore 6. Save. There we go. So now we're happy, we can make all the changes and all the mistakes that we need to make, and we can go back to tutorial 5 in case everything goes wrong. Also, we're going to be reusing a lot of this code anyway. So, what's the general idea? How does this work? I've got another piece of code here that will just give us an idea. Right, hopefully you can see this. Oh, why didn't I turn off gravity? Whoops, I just glitched through the terrain anyway. Let me just turn off gravity. So for my subject or my player's gravity, if you set that to 0 and then rerun it, we won't drop, or we shouldn't drop to the floor, and I can just look down. So this is the new way that I've worked out to generate like an infinite terrain. We're going to have a swirl kind of unravel from the player's position at the center. And so all we've got to do is work out what is going to be the position of the next tile, if you like, as we're going around. So let's go and do a little drawing so we know what on earth is happening. And I just found, I didn't realize this existed. Did you realize this existed? If you put jspaint.app, you can use like the old style of paint, which is amazing. I haven't got a mouse, so I've just got a trackpad. Apologies if this doesn't go very well. But what we're going to do, let's imagine that that is our first piece of terrain, or our first cube, in fact. So we'll go from like a single block this time. We won't have grids, we'll have blocks. And the next block that we want to build is going to be up here. And then the next one is going to be there. And then the next one there. And then this one's going to go down, and then left, and then left again, and now up 1, 2, and 3, and across 1, 2, and 3, and now it's going to be down 4. So it's going to keep moving like that. So that's our first one, number 2. Sorry about my handwriting. Number 3, number 4. No, sorry. Control Z. Sorry, number 2, number 3, number 4. Let's just do number 5, so we're kind of on to the next like section. And so on. So it's like a kind of a swirly system. Now, what we're going to do, I found 2 algorithms of doing this, and I'm sure there's a much better one to determine the exact position that you need to be in. I'm just going to use polar coordinates. It sounds complicated, but it isn't. It's just 2 lines of code to determine the x and y position of our cube. So we position each cube, and then we decide, okay, what position are you at? What height do you need to be, just using the Perlin noise that we were using before. Now, to also make our terrain look a lot better, we're going to run 2 passes of Perlin noise over our terrain. Okay, so I think we've got the basic idea of what we want. Let's go and start the code. Hopefully I'll remember to put like a little link to the beginning. So we've been talking about 10 minutes already. But let's go and do the code now. So make sure I'm in my latest one. So let's go and delete all the stuff that we don't need. Right, we'll start at the top. So we need our Ursina. Window color we can keep the same. We don't need the exit button visible. Previous time equals time now. Leave all the fog. Our textures we'll leave for the moment. Our BTE system, we'll leave all that there. So this is the building system. Build tool can stay, and generate subset. So we're going to create essentially a new generation function. So we'll call it gen sub, or I guess we're not creating subsets yet. We'll just call it gen terrain. There we go. Generate some new terrain. Oh, talking of subsets, let's just go back to our diagram. What we're going to do is something like, how do I make my line thicker? There we go. Let's do it in blue, something like that. So what will happen is our algorithm, our functions, will keep a track of how many tiles that we've laid down. Let's say we've put down 7. It will then make it will make the parent of each of those tiles a subset, and then that subset will combine all of those into one. And then this next load of tiles, or the next 7, I don't know if this is 7, it's probably about 6, annoyingly, there'll be the next subset, and then go pink, and then the next lot will be these guys, and so on and so forth. So just as before, we're using subsets to make sure that our program runs nice and smoothly, we'll be doing the same again, but we're just going around in this different pattern. Also then, what we can do, when we have a number of subsets together, we can then say, let's say we've got, I don't know, 100 subsets, we can then say combine all those subsets together. And so again, we're reducing the number of objects. We've gone from like 1, 2, 3 subsets to just one massive piece of terrain. It's got thousands of cubes in that the program can just think of as one great big model, which it can deal with a lot faster. So that's what we'll do. So we'll have some terrain. We'll have a list of terrains, which will be combined subsets. Then we'll have our list of subsets, just like we did in the previous one. And then we'll have a list of subcubes, which I'll just call cubes here. So it's just 3 lists that kind of nest into one another. Subcube will go into a subset, and each subset will go into terrain. Right. Let's go back to the code. Okay, so we're going to have a new function called generate terrain. Let's go and find generate subset. I found that down here. It's around, in my code, 125. Again, there'll be links to all the code in the description. So, let's just gut the whole thing. This is really scary, but it's all right. We've got the code back there. Okay, there we go. And we called it gen terrain. There we go. Okay, so let's begin working on that. So what we want to do first of all is go and get a cube and put it in the correct position. So we need the current subcube that we should be working with. So we'll call that current. So we need a global variable that we're dealing with called current subcube, or I'll just call it current cube. There we go, and we'll make current cube equals 0, and here are our ghost subset cubes. So how many do we want? Let me just go back to my sample code that's working and already prepared. Number of subcubes, 16 I've gone for. So, okay. 16 subcubes. And it looks like I make 420 subsets, each with 16 subcubes in, before combining it into one large thing. Okay. So we need 16, or I should rather put in here number of subcubes. I'm going to keep all my variables, the new variables that I'm creating down here. So current cube is 0, number of subcubes will be 16. And yeah, it wants to be a cube, and we'll also disable. I found that this is a little bit better for performance as well. So we'll just disable our subcubes there. Okay. And I think, I don't know if this variable needs to appear up here before it appears in the code. Let's just put all that together. So all of this kind of stuff, like the Perlin noise, the terrain with subsets, and all that kind of stuff, I guess is around line 100. So I'll keep that all together, but I'm just going to separate off the new stuff that we're creating. In fact, let's just comment new variables, smiley face. There we go. Okay, so we've created our invisible cubes. They've not got colliders, and they're going to be used in our generate terrain function. So the first thing we want to do is decide where to place new terrain cube. Exciting. So this is where we're going to use our polar coordinates. So we'll say its x position wants to be some origin point, and the origin point will base on the subject's, the player's position. But let's keep that separate to we could just say subject wherever they are x, but maybe we want to, let's say, stick the origin point at where the player is to begin with, and then if the player wanders off, we still want to grow that position from where the subject used to be. And maybe later on we want to say, okay, now, once they've moved 10 steps, now start growing the terrain over here. So the origin is based on the subject position at a certain point, but it doesn't track it all the time. By all means, play with that, and you might have different effects. So it wants to be origin, we'll just call it x plus, and now we're going to do sine. Right, we need the sine function, which we can get from numpy. So from numpy import sine. And while we're here, we're going to need our other trigonometric function, which is cosine. There we go. And a trigonometric function like sine, which just generates a wave, it takes in an angle, or what's usually called theta. I'll call it theta. And basically that just describes going around and around and around in a circle. And then a sine wave will just go up and down like this. Anyway, this will give us, essentially, because we're moving in a circle, but we're trying to find grid positions, the sine and the cosine function, or rather these polar coordinate lines, are going to work out our position on a grid if we're kind of moving around in a circle. That's what's happening. And also, the sine function will take radians, not degrees. So we just have to use the radians function there. So in brackets, within brackets. And radians is not showing up because I haven't imported that. From numpy import radians. There we go. And that function just converts from degrees into radians. And the final thing we need to do is multiply this by the radius so far. What I mean by the radius is the first step, the radius is going to be 0. It's just no distance away from the first cube. Now our radius is going to be this amount to cover all these guys. And notice that we need to move about 45 degrees every block. And so this is our first radius. And so if you like, it's 0.5 away, or we could say 1 block away, or 1 unit away. And then the next radius, let's go to another colour. What will yellow look like? Our next radius will be, I've drawn this really badly, something like that. And then notice that our angles start at 0. The next one will be there. So it's exactly half the 45 degrees. This looks like a complete mess now, but we're getting the idea. Okay, so we need a radius. We'll just call that rad. And now our line is done. So our x position is there. So we need to also take in our theta and our current radius. And again, we need to go and create those. So we need a theta. We'll start at 0, and our radius will start at 0 for the first block right at the center. Okay, oh, I didn't create our origin. In fact, let's go and create the origin where we create our subject, and we can say origin equal origin equals subject dot position. So I think that's going to be a vector 3. Whoops. A vector 3 object. So essentially it will have an x component, a y component, and a z component. I've got to make sure I get those the right way around, actually. Yeah, it'll be x and z that I'm referring to. Okay. So, yeah, so our origin from the beginning of the application is mapped to, or copies, the position of our subject. So that's fine. I went too far. Where are we? There we go. Lovely. So nothing's underlined, nothing's angry so far. So good news is we've done the most complicated bit. So the z position wants to be the origin.z plus cosine of theta multiplied by our radius. Okay. Now, we only want to go and move one of our subcubes into that position and then go and find its height to start generating the Perlin terrain if there isn't already a piece of terrain there. Because you can imagine, you could walk all over the terrain, come back, and then you might start generating or generating some terrain. So what we want to do here is just check there's nothing there, and then if there isn't, we can go ahead. if there is something there, what we want to do at the end of this function is to say, well, increase theta, start going around the radius of what you're trying to generate. Okay, so we want to ask, if there's anything there. Now, the way I got around this was using a dictionary in my code, and I haven't used a dictionary up to now in these tutorials. Good news is they're very simple, and really good news is they're very fast. They're faster than lists. So I think this is a perfect time to use one. Let me just go and find where my dictionary is. There it is. So we've got a dictionary for recording whether terrain blocks exist at locations specified in a key. So I'm going to copy all that, put it into my code next to my new variables. There we go. Dictionary for recording whether terrain blocks exist at locations specified in a key. So if you're making a list, you would use the square brackets. Making a dictionary, use the curly brackets or braces. And basically, inside a dictionary, you have a key and then a value. And a key would look like something like this. I could say, I don't know, mum. And then I could say, she's great, for example, comma. And then the next key, we could have dad. Is like pretty great, and so on. Or more realistic for us, I'm going to record an X position, and then it might be something like at position 3, and then the Z position at maybe position minus 56. And then, if that block exists, I could just say something like hi, or I exist, or underscore, or 0, or whatever I want. Probably the smallest thing, so maybe just I, something like that. And so what you can then do, you can then say sub dictionary dot get, and then you put the key in here, for example, x3z minus 56. Now that will return none if it doesn't exist, or it will equal I if it does exist, i.e. if I've recorded this key and this value, which I'll do, or will do, in the generate terrain function. So if we place a new piece of terrain, we'll record what its position is as a key and a value. And Python is incredibly quick at looking through all the keys and just like going straight to the one it needs. So that's how that works. And at the minute, we don't want anything in there because we haven't created any terrain. So we now want to say if sub dictionary dot get, and so here's where we want to do that. We want to say x plus x. So this x is just the letter x. Sorry, I pointed to the variable. I just mean the letter x because it's a string. Whereas this x is actually that variable, so that's going to be a number. And so what we're doing is concatenating a string. So we're building up that code like x, what did I say, x3z minus 56, for example, something like that. So to make this a string, I just need to wrap that variable in str. Okay, so what, then I need to plus z, and then I'm going to add whatever number we're at here with string, make that string, and just put in the whatever number we've got, z there. There we go. So if that equals I, well actually we'll say none, then we can place some terrain there. What did I do in my version? I'm intrigued whether I says does not equal none, or sorry, does not equal I, or whether I just put equal none. We can also have a look at my so x is cosine. Yeah, we've got the radians. Lovely. Sine string. Oh, does not equal I. I've gone for. Let's do that because I know that works. It does not equal I. So let's just label what's going on. So check whether there is terrain here already, dot, dot, dot. So now we can go and grab our subcube and say what position you are. So we can say subcubes current cube dot x equals x and its z position is z. Lovely. And oh yeah, now we want to record. This is exciting. I'm going to record our first dictionary kind of entry. So we want to say subdic, and then in square brackets, this is how to like assign a value to a new key. We can just copy all of this, thank goodness. This is our code. So that will generate our new key, our unique key, because nothing exists there yet at this string. And you just write equals, so the assignment, I. There we go. So now something exists. So if I try and place another block at this position, it will say I, and so it won't run this piece of code. It won't move the subcube. It will go on to the next bit, i.e. it's going to go down here, else do something. And since we've got this else here, you've got to write something in the next indent block. So you can just write pass, and that will suffice. Although I seem to have an error for some reason. Okay. Let's save that. And actually, I want to know, what have I done wrong? There's something mysterious here. Maybe we'll come back. Did I write? I wish I had like live comments and I was doing this live, then you could tell me in the comments. What am I doing? Oh, no. Else. No, that's fine. Let me just have a look at my code. Else pass. Maybe I've just put it on the wrong. No, I haven't. But oh, this guy was on the wrong indent. Well done if you spotted that. 100 points to you. Very good. Okay. Okay. Let's just put in a comment so we know what this bit of code means. So there was terrain already there. So continue rotation to find new terrain spot, and we'll do that at the bottom. So essentially we just want to say theta plus equals, remember 45 degrees from my amazing diagram in the red. So that first iteration wants to be 45 degrees, and the next one wants to be half that. So divided by our radius. And I suppose our radius to begin with is 0, so we don't want to divide by 0. So we can only do this. So we can only, if radius is greater than 0, then you can rotate or maybe we should no, we shouldn't increase our radius yet, and then divide by radius now that we're safe. So first it's going to be 1, so yeah, it wants to be by 45 by 1, okay. We also want to ask if theta is greater or equal to 360 degrees, so we've gone all the way around, we want to say theta equals 0 again, and radius wants to increment by 1, so we want to increase. And we can fiddle around with these if they don't work. So essentially we're just like increasing that radius, going around the next set of blocks, and increasing it again. Okay. Right, what else do we need to do with our piece, with our subcube? Oh, I guess we want to say, first of all, subcube current cube enable, so switch him on. Sorry, subcubes. And we want to determine his color and things here. Oh, and we need to know his height. That's the crucial thing, isn't it? And we need to parent him. So let's do that. Subcubes current cube parent equals subsets, and we need a current subset. Let's just call that CS. So, you know what? No, I'll call it current subset to match everything else. Current subset. Oh, does that actually exist? Current subset. Oh, we've already got a current subset. Brilliant. So we can keep that. You have been promoted to the new variables. Put that in there. So 0. Brilliant. So later on, if we've collected enough subcubes, then we need to combine the subsets. I guess we do that in here as well. Let's just borrow from my old code, my prepared code. So I enable the subcube, I parent it, we've recorded its position. Yep, we put it in the right position. We've got to find its correct height. We want to map it, the color. Oh, and then we can disable it afterwards. So then we're increasing the, oh, we need to increase to the next subset. Oh, and here we do the combining, else pass. Okay, right, so there's just, oh, the radius limit that we need to look at as well. Okay. I just need a little pause, a little break to collect my thoughts. Okay, we're back. So, what did I need to do? I'm supposed to have prepared myself. So, Okay, so still within this, if we've used another subcube, we want to say current cube plus equals 1, so go to the next subcube, and we want to, just before that actually, we want to disable you. You've done everything we need you for. Again, just switching them on and off these objects or entities can help performance. Obviously, we just use the cube to generate some vertices, to generate the model that we see of the terrain in front of us. And then after we do that, our current cube might be the maximum that we're allowed, i.e. our 16, so that we can generate our, we can combine our first subset. So if current cube number equals number of subcubes, then subsets current subset combine and auto destroy wants to be false. So we want to keep all of our subcubes. I'm just thinking, do I need to disable it after I've done all that? No, looks like I've sorted that out. Oh, and it looks like I then enable this subsets enable. So I must disable the subsets to begin with. So we're going to switch that on in a second. So I sort that out in a second. So then my current subset needs to go to the next subset ready to gather its 16 subcubes next time round. Right, current subset is not being recognized now for some reason. Maybe it's not a global variable yet. Current subset. Is that a bit happier? Yes, that's happier. Lovely. Right, and we need to go and switch off the subsets. Or check that I did that. Here's our empty subsets. So our empty subsets, we want, I'll call it num subsets. Because I've called it num subcubes, and that wants to be for 20. Yes, so that's a lot of subsets, isn't it? And so that's going to be empty. Its parent is the terrain. Well, we're going to have lots of terrain objects, so we have to take out that, and we want to disable it to begin with. That's why we came over here in the first place. So first big change, we're going to have a fixed number of subsets there. Then we're going to disable it, and we're going to take out its parent. We need to set the parent later on when we finish the terrain, I guess we'll call it, or when we combine into a terrain. We'll sort that out. So, okay. Let's return to our function here, and I want to get this running as soon as possible so we can sort out any bugs. Right, we disabled our cube. We haven't given him a color yet. Oh, important thing is then we need to set its height. So we want to do that before disabling it and things like this. So sub cubes current cube dot y equals, and usually here we put in the Perlin noise algorithm, function, the noise there. We're not going to do, we're actually going to create a new function so that both the generate shell and this function are using just one piece of code. It's bad practice to have this piece of code doing the same job as another piece of code. So if you want to make changes, then you've got to remember to change it in those different places. Also, we're going to make it a bit more sophisticated. So let's call that gen Perlin. Generate some Perlin, and we've got to pass in there x and z. It needs to know where we are. Right, so let's just above here, above generate terrain, we'll call it gen Perlin, and it's going to take in underscore x underscore z. I just like to call my parameters variable names with an underscore, just so I remember their function parameters. There we go. So I'm going to now go and copy and paste some code so I don't have to remember all the numbers that I worked out. Basically, I worked out some nice numbers for generating our Perlin landscape. I didn't copy it. Okay, so what is this doing? Here's the noise function, which you already understand. But instead of having a global frequency and a global amplitude, we're actually going to create a temporary variable called y, and it's going to be set at 0. Then we're going to determine a frequency, an amplitude of 42 high, and smooth it out with a higher number. We're going to use the x and the z position that we've passed in from whichever our current terrain cube is, and we're going to add to the value we have in y, and then we're going to add again to that previous thing with now a lower amplitude and another frequency. And basically, these are called octaves, each of these layers. And hence the name, you should have about 8 octaves to have a very realistic terrain. So it'll be really fun for you to play around with these numbers. Usually you go from like the higher kind of basic shape of your terrain, and then the next layer is like slightly more bobbly, and then the smallest layer is like the tiny little bits right at the bottom. Play around with those numbers and things, you get some gorgeous looking and interesting looking terrains. But this looks okay, I think, for our purposes. So we've now positioned our cube in the right position, and this reference we need to paste into our generate the shell. So we just want to say your x, oh, it's down here, sorry. Your y position is, just go and generate or return a certain height. And in fact, I didn't finish off our function. Here we are. We now need to return y. So again, y is this temporary variable. It's just going to return that number based on whatever number we pass in, whatever position we pass in. So that worked for both the shell generation and our generating the terrain in a swirly, swirly, swirly pattern. And to make it look like Minecraft, of course, we want to wrap that with floor. So it'll be at 1 or 2 or 3 or 4 instead of 1.1.2, 1.8, 1.7. If you just take off that floor, you'll have a much flatter kind of terrain, or a less Minecrafty look. Okay, right. It feels like we're very close to finishing. This needed a bit more work, didn't it? What did I need to add at the bottom of our rotationally swirly things. Oh, we needed the rad limit of 128. Okie dokie. So, yeah, if we've done a whole cycle of creating these swirls, we've got back to 0. Theta is 0, so our angle is 0. So then we increase the radius. We only want to generate, say, a certain large amount before stopping for performance issues. Although I guess we could, let's just leave that for now and go and add that later on. Okay, terrain finished. So this is where we want to combine all of the subsets. So I think we finish with the key functions here. We want to go and delete subwidth we don't need, terrain width we don't need, terrain we don't need, frequency and amplitude we don't need. We do need our noise object, our Perlin noise object. We only want to have one octave. We're not going to use its inbuilt octave. And seed, you can put whatever seed you want. I'll keep 99 in there. And subcube index, I can't remember if I'm using that for anything. Let's just delete that. So it looks a lot cleaner now. Okay, so in our update loop, oh yeah, I've just noticed that here's a mistake actually from previous videos. I'm saying if I've moved one block, either on the z-axis or the x-axis, then go and generate the shell. But actually, I'm then not resetting where the previous x and z position was of the subject. So essentially, this is going to run every single update, which is a good idea. So, in fact, let's just move this here. So we go and generate the shell, and then we'll just put pass in there, because this might be useful later on, although we do want to say previous z now equals the subject's current z position, and the same thing for previous x. So yeah, it's just recording where your subject is, or your player is, and then the difference between where your player is at a future time and where we last recorded it could be greater than this. This might be useful for when we've wandered really far or a certain amount, and do we want to start generating the train over there? And we probably do. So we want to change this number to 10 or something, but we're not going to do that now. I'll just leave that like that. This pass just means we're not going to do anything. But we are going to generate a shell every single update loop. This will stop with glitching, me falling through the terrain and things. So if time minus previous time is greater than 0.05, so we want to put this into a variable. We'll call it subspeed. So that just means how quickly are we generating new subcubes, new parts of terrain. Actually, let's call it gen speed, generating new terrain. So we probably want that as a global variable, and we need to create the variable in our new variables place. Generate speed. I found an optimal number at the moment. What was it? Oh, that was the previous. Oh, 0. So basically, we're just saying generate terrain as quickly as possible. You kind of want to increase this number from 0 if you're getting a low frame rate. Only generate them every so often, and then it will be a smoother experience. Okay. Right, back to the update loop. So we don't want to. So if enough time has elapsed, so in our case now, every single update, so 60 times a second hopefully, we want to then go and gen terrain. So we're going to call our new generate terrain function that swirls around, and then we want to say previous time equals the time now. Lovely. And safety net in case of glitching, let's just delete that. I'm sure we won't glitch anymore. And then the giant chicken is going to look at us. Vincent, God bless Vincent, is going to look at us. And then we've got the build tool. Interesting. So what does our code look like? So we've got our imports at the top. So we've got new sine, cosine, radians. We set up the window and the fog, things like that. We've got our textures. Then we've got all our build stuff, which we did the last video. We've got input. Oh, generating the terrain. What we want to be able to do is switch that on and off. Very much like we did with the build mode. We'll do that in a moment if it's working first. Oh, we can take away amplitude. We don't need amplitude from the update. We just need previous Z, X, previous time, and generate speed. We've got build tool. And then down here, we've got our new variables. So we've got our subsets and subcubes, which pre-existed. We haven't created all our terrains yet. So we'll do that if things are working. Then we instantiate all of our, we make our dictionary with the curly braces. We've instantiated our ghost subset cubes. So these are doing all the work to create all our terrain. And now we've got the subsets, which are combining the terrain. And now we've got our new Perlin noise function to get a much nicer terrain. Now we've got a generate terrain function, which we don't know if this works. This is the new engine of our infinite terrain. And we are combining into subsets there, aren't we? We go into the next subset. Oh yeah, if we hit the limit. We're not asking... if current cube equals... oh yeah, then we need to go to current cube equals 0. We need to go to the first cube again. Right, so what we can't do is get past 420 subsets. And now we're just rotating down here. Okay, right. We'll just leave this maybe. Or should we just, we'll delete the finished terrain. We've got 3 by 3 for a shell. Generating the shell. We're using the new Perlin noise function. We don't need amplitude and frequency there. And now we've got our first person controller. We've got some gravity. Oh, let's start up really high. Let's go 64 so we can drop down and see if our terrain's working. And we've got our origin. Which is not changing. So... okay, we'll work on that. Right. Okay, enough program. Then we've almost done an hour of programming there. Or, yeah, about 50 minutes. Let's see if any of that works. Press play. It's actually loading. Okay. Good news is, we seem to be standing on some terrain, and a giant chicken is looking at us. We've got fantastic frame rate, but I can't see any terrain whatsoever. Or maybe if I walk around, will it suddenly, if I've gone more than 16, will it generate a subset? Okay, let's escape. There's no bugs whatsoever, so we've got no clues of what I've done wrong. So let's just make sure I made the radius. We've made theta. We haven't got a rad limit. subsets combine, enable. Maybe we need to add textures and things here. So let's just have a look at my previous code to find the answer quicker. 1 second, I'll just pause and look for it so it's quicker for you. Okay, I think I found the answer. We didn't actually give our subsets a texture. So when we're instantiating our empty subsets, before we disable it, let's say texture equals what would look good? Monotext, I think that's the one I've been using. Stroke mono, okay. Oh yeah, this is the one we can like shine different colors through, isn't it? Yes, texture equal monotext. Okay, save and play. I can't see anything yet. Oh, you know what was also not happening? This should have been updating and updating. So I should have been rotating and rotating. And I'm not getting any new combination records printed out here. So there's something else going wrong. Let me pause again to have a little look. Okay, a few things. In our generate terrain, right at the end, I've put this increment of the radius in the wrong block. We always want to... No, we don't always want to... we don't always want to increase the radius. We want to, if we're at 0, which we are to begin with, it never gets onto 1, but the radius does want to increase to 1 that first time. So we want to say else radius plus equals 1. Let's just see what that does so far. List object has no attribute enable. Where's that? Line 162. Oh, right, subsets. Current subset. Well done if you spotted that bug. We can't just refer to the whole list. We want a particular subset, particular entity on the subsets list to actually enable. Oh, then we would definitely not see anything if we've never got to that. I'm intrigued whether this... It's kind of nice because it's only 6 lines, but it's not that pretty. Whether it works, it's slightly different to my prepared code. Oh my goodness. Yes. Oh, this is brilliant. This is exciting. It's working. And 60 frames per second. Lovely. And notice I've moved away from the origin point. The origin point is over there, and it's still generating until it's kind of like happy, and it will keep on generating. So we need to sort some things out. The other thing is we've got our subcubes overlapping and things. And that's because I didn't use our floor mathematical function up here. So when we're deciding where the terrain cube needs to be, we need to put it onto a grid. So we just need to wrap that whole thing in floor. There we go. Let's just run that again. And now we can see basically there's a cube running all the way around the terrain, and if there's not a cube there, it will add itself. And our shell terrain is adding itself, is generating its Perlin heights and things. We can see some gaps appearing. That's because, as I said, my dirty little algorithm is not great. So there's one little hack for us. And what that is to, instead of increasing by 1, we'll increase by 0.5. I think that will take those gaps away. The next thing we need to do is basically tweak it so that we can generate terrain as quickly as possible, but balancing our frame rate. At the moment, it's just positioning one block, one cube, every update cycle. And what we really want to do is generate as many as we can each cycle, so far as it doesn't kind of disturb our smoothness. So to do that, what we need to do is if we go to the update function, here we are, when it's time to generate some terrain, we're only running that function once. So in other words, it's only placing one cube. So we want to say for I in range, so we're just creating a little for loop, and we'll just say per cycle, I think I called it, and that's just like how many cubes do you want to create, and then we'll put that in the block there, and per cycle will need to be a new variable. We'll add that to our list of global variables so we can assign it out here and refer to it in the function. And it's kind of related to the generate speed. And I think we want to match 16. Is that what I did in my original? Yeah, 16, 16 and rad limit. Okay, let's just see if our terrain is generating a little more quickly and just have a look at our frame rate. Okay, so that's a lot quicker. Our frame rate's now dropped, but I'm recording and I'm not on a very fast computer, and it's, I wouldn't say silky, but it's like satin. It's not bad. Okay, that's good. Right, so what do we need to do? We need to be able to change the origin position and to stop swirling or generating terrain when we don't want that to happen. So I'll just do those two things. We're going over an hour now, and next time I'll show you how to load in models to make everything look a bit more gorgeous and to add colours and things again. So I'm pretty happy with this. We've got an infinite terrain working. I haven't tried building stuff as well. So anyway, in the update, if we've moved 10, is that what I do in my original? Oh, I've just done 1. Let's stick to 1 then. So if you've moved 1 block, then first thing you want to do, take out the pass of course, first thing we want to do is say origin equals subject position. So we've got a new subject position. Also, we then want to say radius equals 0 again. And is that all we need to do? We do need to add radius and origin then to our global variables. I'll just make another global line. Global radius, global origin, so we can refer to those. Yes. What would also be nice is if we're actually generating. So are we generating will equal 1 if it's on. Make ourselves a note. Is it -1 if off? And then we can do that toggle thing. The toggle thing. So where is, yeah, generate terrain. So what we want to do here is if key equals G, then we want to say generating minus equals -1. So if it was -1, it's now going to be 1, so it's generating, and if it was 1, it's now going to be -1. Brilliant. And generating doesn't exist, so we need to add that as a global variable. So that's how we can switch off generating the terrain. And really, yeah, if we're saying I want to have a new origin and start generating some more terrain, I want to say generating equals 1. I want to switch that on. Again, generating doesn't exist in our update loop, so we need to, or update function, so we need to add the generating as a global there. And another little tweak actually is, what if we wanted to just switch off generating the terrain and we move more than one terrain unit, then we've just switched on generating terrain again, so we can't like move without switching on. So we only want to be able to trigger this if we want to be able to trigger the terrain, the generation on. So we need another variable called can generate, and we'll say equals oh, there we go, -1. So yeah, it sorry, I'm very tired. So it's just another negating or toggling kind of system. So it needs to be 1, and then it's going to be -1 if off. Sorry, it was a double negation. That was too much for my little brain. So I want to say generating equals oh my god, equals 1 times, whoops, I made a dot, times what did I call it? Can generate. So that means if we can't generate, it's going to be -1. So generating is going to be off. And up at G, we want to say, yeah, generating is off. And we want to say can generate is toggled. So if it was -1, it's now going to be 1. If it was 1, it's going to be -1. That is quite complicated. I should be more fair to myself. For getting a little bit tongue-tied and stuck there. It's okay. It's just a little bit complicated. That's all right. Okay, so let's go and run this. That's my congratulations. If you've watched this video so far. Ooh, we dropped a little bit into the train there. That wasn't good. A bit of clash detection. It is very fast. This is nice. And can I like run backwards? Yeah. That's nice. And so there we go. Anoush is generating the terrain in the invisible places. And if we stand still, we can let it kind of like grow around us. Do fiddle around with the numbers and things. And maybe if you've got a more powerful, you probably have got a more powerful computer than me, you'll be able to generate terrain a lot faster and a lot smoother. So if I go down here, no, if I go over here, I'll let it generate next to Vincent and then see if we can switch it off. So it's generating, press G, it didn't switch off. So all that complicated stuff was not working. Okay. Generating equals. Oh, that's because we're saying if generating equals 1, then. Oh, wait a minute. We don't want that there, actually. We want this. Where's our generate terrain function? Yeah, we want to say global generating, and then we want to say if generating equals -1, return. Don't run this. That's the best place to put that. So what I didn't do was the simple thing, which is, well, if I'm not generating, don't run the function. I was just letting it run whatever was happening. Okay, so it's running. If I press G, it stops. Lovely. And I can run around and it won't trigger it generating. Perfect. If I press G again, I've moved more than once, so I've got a new origin point and I'm here. Very good. Okay, so what I need to do in the next video, let's have a look. Change building block type, done. Prevent building when already, oh yeah, we need to finish that. Or actually, I'll put this up. We can delete these two. And actually, we'll call that number 1 and we'll say mining, question mark, and 0 needs to be combine subsets into terrains list. That's what we need to do next time. Right, thank you very much if you watched, and hopefully you'll enjoy creating interesting infinite terrains. Right, goodbye. Leave any comments if you have any questions and things. Goodbye.